All right, so we talked about ratio and proportion in our last lesson. Today we're going to talk about similar polygons. Most of this should be kind of a review for you of stuff that you learned in one of your junior high math classes. So, what are similar polygons? First of all, similar polygons are ones whose vertices can be matched up so that their corresponding angles are congruent and their corresponding sides are proportional. That means the ratio of the matching sides is the same. So the ratio of the lengths of the corresponding sides of two similar polygons is called the similarity ratio or scale factor. I think that your book in junior high called it a scale factor. Your book calls it a similarity ratio. It's the same thing. So, for example, let's identify the pairs of congruent angles and corresponding sides here. We're actually going to do a little bit more than that. First of all, we're going to do the congruent angles. So we'll say angle S is congruent to angle Z, and that angle Q is congruent to angle Y, and therefore angle R has to be congruent to angle X. Do you guys remember why that is? What theorem lets me know that this last pair of angles are congruent? Yeah, it's the third angle theorem. Yeah, the third angle theorem. So that's the angles. For the sides, it's going to be a little more involved. What I want to do is you always want to match up the biggest side with the biggest side and the smallest side with the smallest side. So I'll start over here, and I'm always going to go left to right. You can always go right to left. It doesn't matter as long as you're consistent within the problem. So I'm going to say QS goes to YZ. That's 18 to 12, which reduces to 3 to 2. Then I'll do the medium ones, RS to XZ is 13.5 to 9. Now, when you're reducing something like that that has a decimal, you got some choices as to what you're going to do to simplify it. In this case, since it's 13 and a half, I would just multiply top and bottom by 2 and then reduce it. So it's like unreducing. We'd multiply those both by 2, that would be 27 over 18, both of which are divisible by 9, which is 3 to 2. Now, if you can look at the 13.9 over 9 and go, oh, 4.5 goes into 13.5 3 times and into 9 twice, that's fine. Not everybody can do that, and so it doesn't matter. And then we'll do the two short sides. So that's going to be RQ to XY. That's 9 to 6, which is also 3 to 2. So what's happened here, you don't need to write this, but the corresponding angles are congruent. The corresponding sides are proportional. So corresponding angles have to be congruent, the corresponding sides have to be proportional. If we have both of those things, then we're going to have similar figures. And I guess it's probably tomorrow we'll learn some shortcuts for triangles where you don't have to know all of those things. Sort of like we did for congruent triangles. All right, so let's go on. Determine whether the polygons are similar or not. If so, write the similarity statement, which is where you say this is similar to that, and you have to make sure the corresponding vertices match up. And the similarity ratio, which is just in this case, the similarity ratio would have been 3 to 2. All right, so here, it tells us that these are both rectangles. And it wants to know, are these two similar to each other? Well, there's two things that you have to check. Are the corresponding angles congruent?
Yes.
Why?
Because all angles in a rectangle are 90 degrees.
Yeah. So in both figures, all angles are right angles. So it doesn't matter how we match them up, that's going to match. Now we need to check, are the corresponding sides proportional? So if we check PQ to TU, taking the two bigger sides, that's 12 to 16. That's 3 to 4. What other two sides are going to have the same ratio without doing any other work?
SR and WV.
Yeah. And then let's check the other ones. PS to TW is going to be the same as QR to UV. That's going to be 4 to 6, which is 2/3. Are the corresponding sides proportional? No. So these are not similar. Not all rectangles are similar. Are all squares similar?
Yes. No. Yes.
Because the corresponding angles are going to be congruent. That's not a problem. And the sides have to be proportional because the ratio is going to be the same, whatever the side lengths are, because they're all the same. What about two rhombuses? If you have two rhombuses, will they always be similar to one another?
No, because the angles.
Yeah, the angles don't have to be the same. The sides are going to be proportional, but we don't know that the angles are going to be the same. Okay, now if we knew that each of them had an 76-degree angle in them, well then yes, we would, because then all the corresponding angles would be the same. All right, let's take a look at this one. So let's work with the angles first. And you're like, well, how am I supposed to do that? I don't have all the angles. But you have enough information to find everything you need here. Because what kind of triangles are these?
Isosceles.
They're isosceles triangles. And therefore,
the base angles are congruent.
exactly right. Therefore, the base angles are congruent. So here, I'm going to take 180 minus 36. And that's 144. Split it in half. Each of these are 72. Here I'm going to go the opposite way. If this is 72, then angle S has to be 72 also. And if those two are 72 like these two, well, I don't even have to do the arithmetic. I know that's got to be 36. So, are the corresponding angles congruent?
Yes.
Yes. Now I just need to check, are the corresponding sides proportional? Those are always the two things that we need to check. So, corresponding sides proportional. I'll start with the big sides. So, QP to TW is going to be the same as QR to TS. That's going to be 5 to 17.5. You actually have a couple of choices. You could multiply them both by 2, but you could also multiply them both by 10, would get rid of the decimal as well. I'm going to multiply them by 2, so that'll be 10 over 17.5 doubled is 35, which are both divisible by 5. That's a 2 to 7 ratio. And then we'll check the short sides, PR to WS is 1.8 to 6.3. Now, doubling isn't going to work so well for that, is it? But if you multiply them both by 10, you get rid of the decimal just as nicely. So it'll be 18 to 63, both of which are divisible by 9. That's 2 to 7. So yes, the corresponding sides are proportional. So the similarity statement would be like this. Triangle PQR is similar. The symbol for similar looks like the symbol for congruent, just without the equal part. Remember when we first talked about congruent, we said the top part said they were the same shape. You know, the squiggle was same shape and the equal was same size. Well, here we're just saying they're the same shape. They may or may not be the same size. In fact, in here, I know that they're not. To TWS, WTS. So that's the similarity statement. And the similarity ratio is what? It's 2 to 7. We already found that. Okay, questions? All right, your assignment is in the book.